Okay, I think we just can get started. Hi everyone. Today we're going to talk about how we taming a beast, the move to declarative validation, API validation in Kubernetes. I'm Yongrui Lin from Google. So first we'll talk about why we're here. So currently it's the shared burden for both users and maintainers. So for users, when they submit the request to the API server, there may be some hidden logic they don't know. For example, when they run the kubectl explain, it's incomplete. It's because the validation logic is hidden in the Go code. It's not explicitly showing to the users. Sometimes when they apply their configuration, you'll fail to some unrelated legacy field. They don't know why it failed, because sometimes the rules are changed silently. They are not put into the contract with the users. And for maintainer, it's also a toil because they need to review a large bunch of validation code, especially when there are API changes. So they are hard to put the LGTM on the PRs. And because the validation code is so hard to understand, then you intimidate the new contributor to come in. So we can see below there are images, the photos about the API review. How many comments are they? Although not all because the validation review, but it still take up a bunch of the review comments. So why it was so hard? Because currently there are 19,000 lines of handwritten imperative validation Go code. It's duplicated across 20 more validation.go files, one for nearly every API group. So this is some hidden API that is not explicitly shown in the API documentation and somewhere else. You can see the tables. They come up in every API groups and add out to the 19,000 more lines of code. And it's responsible by every 6. So we have the vision to solve this problem. The vision is from imperative to declarative, like the API principle. Our solution is a fundamental shift in thinking. We want to move the validation logic into the API itself, attached to the fields, so that user knows what they are going to encounter when they hit the request to the API server. So they are going to add the Go tags directly to the fields attached, and we create a new tool called validation gen. You will create the Go code automatically with the validation logic. So it will result in consistent reusable rules for all the APIs. So we put up into a cap. It's called declarative validation for Kubernetes native types with validation gen. So we can take a quick look what it looks like. In a way, the validation code is written by hand. You can see on the left is trying to validate for the replication controller, replicas, and you're trying to verify that it's non-negative. So there are 15 more lines of code. You need to look into it and understand the logic behind it. But in a new way, you just need to add the tags there. You can just have these 3 simple tags. You can easy to understand that they are required field. They need to be a minimum to 0. So which one do you like to review? I think you're more likely to review simple tags there. So it will result in a virtuous cycle. So API also just need to add simple reusable tags. The tools will generate the optimized Go code. And API definition will become self-documenting and machine-readable. I think it's easier for the new AI to understand it. And the reviewer will drastically reduce their toil and focus on the design instead of reviewing the boilerplate of the validation Go code. And the barrier of entry is lower, so you will generally increasing the contributor velocity. So we're going to dive into how it works for this magic happen, the validation gen. We have overview is that this binary we're going to parse the Go struct tags in types.go where the APIs are there. and you will support a rich set of validation rules, from simple one like the require optional and some value validation like minimum, maximum, and to some semantically validation like immutable, and some Kubernetes specific tags like list type for server-side apply, and then some more complex tags as well for union members, like for the equivalent in a open API that's one-off, and some items for more cross-field complex validations. So if you like to know what exactly the validation gen currently support, you can run the validation gen --docs. It shows up all the supported tags. So in general, after the tools that parse the tags, you will generate the zz_generated.validation.go, which has the validate function inside it. So let's take a concrete example to see how it works for the API author they need to do. So first step, they'll add labels, add tags in the types.go directly. Take the previous example. It will add the minimum tags to the fields. Then you will run the update codegen script, which is also a part of CI. Then you will run the code generator, generate the codes in our source tree. During the meantime, the validation gen binary will using Django to parse the types as AST, which will explore the code struct, and then to see what's the validation attached. Because in the meantime, you will find the tags and will invoke our register minimum validator plugin. It's kind of the architecture we adopt. Like each tag has its own plugin, so we can easily add new validator, which is responsible for different tags. Then you will generate a Go code. The logic is on the right. Is using the Django to generate the code automatically. It has the validate function in itself. It will return a arrow for the validation arrows. And finally, after the code got generated, it can be called during a runtime. So the API server will call these generated functions we generated inside, and we will bundle together into our during the strategy here. Like this is the REST strategy we use. So you can see it's currently is running in parallel with the current old handwritten code, and we have a special handling for how you can call and run the generated code for validation. So we can see there's some more highlights for this kind of strategy. You can simplify the complexity with tags. I will take a more concrete example to explain. On the left is the handwritten validation logic. It's trying to validate for the CSR conditions. You will need to make sure that for the conditions, there's no the types of approve and deny coexist at the same time. And especially for the updates, if it would need to check if there is already this kind of invalid case exists. If it's already exists, it will skip the validation, kind of like the ratcheting logic. But on the right, it's the new way we can do. We just need to add the tags there, just those 4 lines of tags. And here is the 0 or 1 of member tags. It will verify basically the same logic on the left. So it's like shrink the dozens of lines of Go code into 4 simple tags. Before we dive into the next highlight, I want to also talk about the challenge. We have always have a hard time to evolve the validation because we need to make sure it's backward compatible. I will take an example here that you have an all object with replica equal to 1,000, and you want to add a new rule which is safer. You want to make sure that the replica is maximum as 100. So the old object basically is invalid. But you have an action now. You want to add update to the label, which doesn't touch the already exist replicas. So in the current result, if you directly add a simple validation new rule, it will fail because the new rule doesn't allow the replicas to be exceed 100. So the consequence is that if you want to update the handwritten validation code, you need to make sure it was backward compatible. So in our new generative code, we cover this case because we have ratcheting there. It's a core built-in feature. So all the framework will automatically adopt this feature. We have principle that any store configuration are considered valid, even if it is invalid in the new updated validation rule. And we also have a principle that the API request should not be rejected due to the fields you are not changing. So if we take the previous example, we have the replica equal to 1,000, and we add a new rules with the case maximum equal to 100. You will generate a code which has a ratcheting logic embedded. Then the user action will pass. Because the framework saw the updates and it sees that the replicas doesn't change, so it will ignore and skip the validation. So this is a very critical change and at high risk because it's touching the Kubernetes API interaction with the users. So we need to take it very carefully. So we have defined the safe rollout strategy. We define the tag stability, just like the metric, but it is defined on the tags. So we have alpha, beta stable. Alpha is for the experimental new coming tags, and the beta is for the well-tested and not expected to change. And we hasn't promoted any tags to stable yet because it was going to be used for production environment, and it can be used for the DV-only stuff. I will expand the DV-only later. So the reality is that for these, the simple tags we already tested and created for a couple releases, already been beta. But for those complex tags like the 0, 1 off, and then items and immutable with some discussion still ongoing, they are still in alpha. So currently in 135, we don't have any stable tags yet. So here is our plan. We initiate this project in 133, and we complete the most critical framework in 135. And in 136, we are looking forward to have our first stable tags, which can be used for DV only. So yeah, and ongoing, we still need to migrating the existing APIs and adopting it in the new APIs in the next couple of releases. So I would talk more about how we can make sure this migration works carefully and safely for the entire repo. So we have two feature gates. The first one is called declarative validation, which means that if it is enabled, then the generative validation code will kick in during the validation process. And it doesn't affect any logic with the handwritten validation that existing in every API groups. And the other is the declarative validation takeover, which means that the generative validation will take over. So it will roll out the validation result from those fields has been migrated. But for now, currently, it's still default to false, so that the handwritten validation still remain authoritative. We also have a runtime verification. So because currently both validation run in parallel, so we'll compare the validation errors. So make sure there's no mismatch between them. So we can prove that the generative validation and the handwritten validation are equivalent 100%. So here's our plan to do the migration. The phase one already finished. We proved the equivalence basically in the 133 and 134. We have these two feature gates. The first one is on and the other is false, means that both generative validation and handwritten validation run in parallel. And we collect the metrics these metrics supposed to be 0 to prove that the generated code is equivalent to the handwritten code. In 135, we keep monitoring so that we can gather more confidence that we can finally graduate some early beta tags. And in 133, we look forward to graduate some tags, and then we can start to adopt new APIs with the DV-only stuff. So DV-only means that there's no handwritten code for the API validation. It will be purely based on the generic code and their tags. So in the future, we're looking forward to the declarative validation-only APIs, which means that the validation logic will attach to the types.go, so the user can see it, and they can have these declarative validation native marker tags attached to them, which means that user can know these fields with this validation are only in the generated code, so they don't need to review the handwritten validation code anymore. They just need to review the tags there. So the result, the system can bypass the legacy validation code hooks for their types. So the requirements that, but this is only for those tags are already be graduated to stable. But we still have pragmatic notes that there are already existing some very complex and messy handwritten validation, so maybe they are never be migrated and will stay in handwritten forever. Okay, so I would also like to kudos for our contributors. They contribute to our project. There we also did a lot of migration already in 135. So last one is want to call out to all the 6 to join our effort. We still want to continue to migrate all the handwritten validations to adopt to using the tags so that in the future, the API reviewer will reduce a lot of their work, and the user can know better about what will happen after they send a request to the API server. So, but they can, so in 136, we're going to graduate the one set of tags, and then after that, if you have new validation, you can consider using the stable GA tags, and you don't need to write for the handwritten validation anymore. But if you want to use the still in beta or alpha tags, you still need to write both so we can make sure that the logic are equivalent between the generated code and the handwritten code. And for existing APIs, we also call out for us to do the migration. And I think it's a very fantastic, good first issue for the new contributors. We already have some PRs merged for the new contributors to come in to do the migration, so they can either learn how to construct their APIs better and how to review, to help the reviewer to better understand the validation logic. Yeah, I think that's pretty much it. And if also ask if you want to join us, you can read our cap. It's a long cap. You may spend some time reading on it. And you can also join our Slack in a SIG API Machinery and a sub-project channel, SIG API Machinery Dev Tools. And we also have a sub-project meeting every 2 weeks in Tuesday. It's called Declarative APIs and Linkers. Yeah, okay, that's pretty much it. I think we still have 10 minutes for questions.
Hello. Oh. Thank you. I want to be clear for everybody who is now chomping at the bit to go jump in and help, which I know is all of you. The things we're most interested in is if you're writing new API whether that's fields in existing types or whole new types, that you do the declarative validation at the same time so that you can be sure that you're writing them with the patterns that we are codifying for declarative validation, so that when you handwrite it, you're not going to do anything surprising and be stuck in that legacy corner where we don't want to be. If you're going back to things like pods and services and trying to convert fields, that's a little more challenging and a lot more delicate. So if you want to go there, please feel free to explore. Understand that there will be some caution as we convert existing APIs. But the goal of converting APIs is so that we can learn what validation patterns we need to codify into new tags so that new APIs can use them. The real goal here is to save future time on API reviews.
One thing I'd like you to add, if you don't mind, Tim, if you want to add something, please go to the working group. If you want to add something, as you said, to pods and services, pretty please come to the working group.
Just again on the mic, if you want to add something to pods and services, please come to the working group and talk about it. Pod is not wired up yet, right? Each type that you want to add add declarative validation for needs to be wired up and have the test harness installed. We haven't done pod yet because, oh my God, that's scary. But if you want to do other types, please come to the group and talk to us. They're pretty eager to help you get the wiring done and then send you on your way. And ultimately, the test cases that come out of this are significantly better than the manually written test cases. So we're actually improving the code quality by doing this, and also by deleting crappy code eventually.
So I'm curious, for the migration path there, do you have some way that you're keeping track of when you find like the handwritten validations that you don't necessarily have a declarative validation tag for? Are those being created as like issues against validation gen, or are those being tracked somewhere as like future work to do, just from an outside perspective of like what are good tags to like start contributing for?
Yeah, so we have a very ground rule is that we don't want to have tags that only use in one place. We want to introduce tags that have a general usage. So if you have found some edge cases, you can come to the working group to see whether there's other common patterns. Otherwise, we may be we could need to work out a solution that whether we need to update the handwritten code to make it to be more general cases, or it may be a very specific, complicated case may stay in handwritten forever.
I'll say we have a dev branch too.
Yeah, we do have a dev branch where we're working on additional tags that we haven't put into the main branch yet. So that's a good place to add new things, try new things, and build stuff out. It's a little faster, higher velocity, and then when we're sure we've got something in a good state, we bring it over to the main branch. Also, we do, in the handwritten code, we do add a marked by declarative on things that have been migrated. So you can see where things have been migrated, which can help you a little bit in figuring out what has and has not been done.
I also want to quote Tim and Jordan for a second, but when it comes to new validation rules or new annotations, we want to exemplify best practices. So the API reviewers are going to care and are going to want to make sure that what we're adding is actually, moving in the right direction. So it's not just the working group, it's also going to be the API reviewers.
So I'm aware of some of the markers that don't exist yet in DV that would have parallels in, say, QBuilder. How do we feel about adding, for example, Kate's maximum, which I don't think is implemented yet, but also, as far as I can tell, hasn't been needed yet in DV, but would be something that's very important for CRDs and an eventual world where CRDs and built-in types have all the same validation markers?
Do you want to answer this, or do you want me to take it?
Yeah, in general, we want to pursue that the CRD tags are in the same to the native types, but currently there are still gaps there. We're going to have the tags for the maximum, but for now we hasn't find the actual apply places to it. But eventually we'll have it, and we're going to make sure it was complying with the CRDs.
The other thing I will say is Lilit on the working group is actually the person who is currently tasked with trying to make sure that we have a consistent set of annotations across both native types and CRDs. So it is a goal, and unfortunately Lilit's not at the KubeCon this year, but definitely come to if you're interested, come to the working group and chat with Lilit, because that is what he's moving towards.
Also, not all of you may have come to the talk this morning about the Kube API linter system. That's actually very closely related to what we're just talking about now, because we now have, you can write a CRD, you can use OpenAPI to write that, you can write a native type with Go, you can use KubeBuilder to write a type with Go. So there's 3 different ways that you can write an API. One of the things that's really interesting about declarative validation is now that we're adding tags, it starts to look a little more similar to KubeBuilder in the idea that everything you know about your API is all in one Go types file. So then, of course, the important question is, are those things going to align? Are we going to be able to ever use Kube API linter to help us develop in-tree?
Yes. There is a open tracking issue, 134761, I think, off the top of my head. Not burnt into my brain at all, which is talking about how we're building the linter into KK. There is still a lot of work to do in the Kube API linter project around adding DV understanding. So if anyone is interested in bridging that gap, PR welcome.
Well, and we also just merged into Kube API linter, I think pretty recently, support for it actually being able to parse out declarative validation tags and determine that it is a declarative validation tag, and that it should be, set aside for a linter to now be able to understand this is declarative validation versus this is a KubeBuilder marker, in case there's any differences between how they're represented for either of the style of APIs.
So what about self-validation? Is it going to come to the core APIs? Is it going to be removed from the CRD? What's waiting for us?
So it's my fault, so I'll talk about that one. I do not want to see cell overused for things that we can do in a clean, simple way in the APIs. We added it mostly because what we saw was a proliferation of webhooks being added, and we thought that was worse than having you write some code right into the CRD. But yes, we absolutely want structured, reasonable tags.
I will kind of add on to the question. I think I know the answer, but I'll throw it to you, which is some of these things can be compiled if they're native types, but I don't think we can compile for CRDs. So does that imply then that some of the annotations that are compiled on native types are going to have to become cell rules for CRDs?
Joel might.
There's maybe some prior art here. So I'm going to say 2 or 3 months ago, we added exactly one of marker in KubeBuilder, which is implemented as a cell rule. The cost on it is static, pretty much, based on the number of things that are going, and it's not expensive. I worked out, like, worst case, you're end up in like 100 cost units, which is nothing. So yes, cell will not be going anywhere, and it will most likely be used to actually implement some of the DV tags by controller gen internally.
There's one other step we're going to take. So for example, I got 2 issues in the last few weeks where somebody couldn't validate map keys because OpenAPI 3.0 doesn't support that. And so the solution, I don't think the solution is to use cell there. I think the solution is to get built-in support to validate map keys in a native way with OpenAPI.
Declarative validation does.
Yes, declarative validation does that. So we're trying to bring things together.
So how do you find balance, like, between the validations that are there in CRDs? So as someone who writes CRDs, how do you find the balance? Like, what validations will I be putting still in the CRDs in form of set expressions, and what I would be using the, like, KubeBuilder declarative validations? Or
You won't have a mic here.
Do you want to get that one, Yongrui? Should I get it?
You can get it.
Okay. If you can do it with the open API tags, that's the way to do it, right? So if it's logically like a format, and you can just say format : the name of a format, and that format maps to some regex, just do that. If you have minimum, maximum, set those. Cell should mostly be used as an escape hatch that's not as bad as a webhook if you need the escape hatch. And sometimes people are doing really complicated multi-field checks and things like that. So that's how I'd approach it.
So as a concrete example, I would not expect a union, like a discriminated union, which we use a lot in OpenShift APIs, to be validated as an open API thing, because there's nothing that we can use to relate the fields. But we do that with Cell today, so I'm expecting in the future when we implement the case union style tags, that will just generate that field relationship through Cell.
And my interpretation of that question as well was also like, when do I use the declarative validation tag versus when do I use like a queue builder tag? And I think that and Joe and whoever else can correct me if I'm wrong, but my understanding is that we eventually want to get to a point where we're kind of converged and there's like one set of tags that you can use for both built-ins and CRDs. And so I'd expect there's probably going to be cases where you're still using queue builder tags, but as this project progresses, you'll probably start to have a mix until you end up having mostly DV tags.
I'm also going to go back to one thing I think Yongrui said, which is that our goal is to use DV annotations when there's more than one instance. I don't think that has to just be native types. So if you are starting to write the same cell rule for many fields, please come to the working group, because maybe there's something you can definitively, helpfully contribute there.
I have a totally different question that maybe you want to talk about how we will do things like feature gates with validation, the options support.
Yeah, we do have tags that provide these kind of feature, but it hasn't been used anywhere. We already provided the if enable. You can include an argument with the feature gate status. So you will, in a runtime, you will to use the feature gate status to determine whether you need to run the validation or not. It's also attached to the field. Yeah, it's already there, but it hasn't found the usage now.
So for all those people who've handwritten validation that says, if the option is set, or sorry, if the feature is enabled or the option is already, this field is already in use, then pass the options field through the opts struct all the way down into validation, and then in validation you check the opts field. All that is handled by a single tag. Whatever, we got the right logic.
But the strategy.go has to be still.
Yes, you still have to update strategy to say that this option is enabled. And then the validation then can see it as a list of enabled options.
Do you want to relay it?
So how about how could DV support such validation? Increase only when patching or something. So most tags displayed the slide could fit invariants for resources. But we have several fields that increase only when patching or something. So how could DV support such like the use cases?
You mean update the fields and the text is not there? Or you mean
No. We have validation logic increase only when updating, right?
Yeah.
Yeah. So how could declarative validation support such cases or not? Or in that cases, we should still using handwritten?
Yeah. We differentiate the create and update. So in the path of the request, it will take along the operation types, which is create or update. It will differentiate between.
You also have access to the old value of the field.
Okay. So declarative validation also.
Yeah, it parallel traverses the old data tree and the new data tree, so you know what the old value was when you're
Okay, thank you.
I don't think we have a standard way to say if the current operation is an update, then the limit is X. Otherwise, the limit is Y. Do we actually use that in any APIs?
I don't think you actually need that though, because if you need a validation that means that your like an integer field is only ever increasing, if you have the old and the new, you can just make sure that the new value is only greater than the old. Right? Like.
Are we on? Oh yeah. I will have to go look at that use case. I don't know what the specific use case is. If you have a field in mind, can you just send it on to us and we'll take a look at it?
Wait.
Is that what you mean? Just monotonic increase?
Yeah, monotonic.
Oh, I thought you meant like we're ratcheting in a change, but you can only do it through updates. I got it. Monotonic seems like a perfectly reasonable tag to add.
Yeah, we have that use case for OpenShift as well, where we have a couple fields like that.
We've implemented, what, like a dozen or 20-ish tags. We know that really the full set of tags to cover everything we do is going to probably be more like hundreds. So when it comes to things like maximum, the only reason we don't have it is because we haven't had a use case for it yet. Right. Every time you add a tag, you got to add a bunch of test cases and whatever to make sure it works. So we're happy to add them as we come up. Monotonic seems like a perfectly reasonable one.
I think we're on time, so yeah, we can take it offline. All right.
Thanks, everyone. Thanks, Arm.